Hello, friend. Welcome back to another week. Another stream. Maybe my video ain't updating. Let's see. OBS is acting weird. I'm with you. I'm with you. How are we doing here? Oh boy. Super fun times. Oh no, what's going on? Oh no, it's not going good, was it? Oh. Oh, hiya. Oh, maybe my cable got damaged. No. That's probably what it is. Oh no, my webcam cable. Looks like it got smoked. It was kind of working, but... Oh no. Okay. Might have a backup. Gonna have to take a pause here for a second. Okie dokie. Let's see here, friends, if I have it working. Okay. Boop. Center that over here. Happens, you know. Cable you've been using forever, suddenly no good anymore. For some reason. Who knows? Good to know, though, that we're here for another week of hacking on some Haskell and messing around and learning stuff. Hope your week has been pretty good. Mine's been, well, I mean, it's been okay. A lot of rough news out there going on right now. And, you know, it's kind of unfortunate what's going on. You know, I don't like it. It's been weighing on me. As I'm sure it's been weighing on everyone. You know, hearing from open source contributors that I've, you know, worked with online and known for some time, and no good. But we're here now, and we're going to work on some Adventure Engine. So last week, what did we do? We got part of the way through, I believe, implementing save files. Some kind of system for that. So we're going to continue on with that this week. Why not, right? So we have, let's see, I think we were starting to put it in the engine. Some save game state stuff. Yeah, looks like it. The save game state thing will be eventually a special command that you can input to save the current game into a place somewhere. And we were experimenting and learning a little bit about different approaches to implementing effects so that our code can be testable. Maybe went a little bit overkill, but maybe not. Who knows? So the idea here was that we were gonna like kind of come up with this interface for like writing and reading files. Nothing too out of the ordinary or extraordinary. And yeah, the reason why we wrote it this way is so that we could have this instance here, for example, of read file where we read from some stub file we can create in memory that returns like the exact text we want it to return. And we don't have to bother with actually reading and writing from the file system just in our test suite, right? We're still going to obviously test with a real file system and do that. It's something more like an integration test, but I don't think we need to spend too much time automating that because we're kind of like playing the game as we go, making sure everything works there for the most part. So, and that's because like if you don't trust the library underneath, I guess, you know, for reading and writing file paths, you might want to integrate that integration test with that for different file systems that you're actually going to run this program on, that kind of thing. Anyway, diving too deep into it. Let's just get to some code here. Now, I think what I was kind of struggling with a little bit was like, we don't want to like test reading and writing files because we can just assume that probably works. But the libraries that implement those services for us are themselves really well tested, and so on and so forth. So it's not terribly interesting for us to know that we can read and write a file. But we do want to know that the files that we write have the correct contents. So we want to make sure that we're writing out all of the game state that we're interested in, so that when the user like, loads up game state from a file, that the engine is in the correct state when they do that. And similarly, when we write out a file from a particular state, and then we read that file back in, the engine's still in the same state. And that's kind of like where I'm going with this. Okay. So yeah, let's start using a bit of this stuff. So it should serialize the JSONs given the default game state. I think actually what I was mentioning there was going to be a good test. You know, if we write this, if we serialize it out to disk and we read it back from disk, that where the game state is still in the default state, exactly where it was. Right, we might do a couple examples of that where we start with the init state, we change something about the init state and do that same operation again, and just make sure that when it loads back from disk, that the engine is in, you know, has the same tweak to it, is in the same state as when we serialized out the game state. And that's kind of like what sail files are for the most part. So, what do we need? Well, we need to determine what we're going to pack in there and stuff like that, but let's see. It should restore, save and restore to the same state. I think, in other words, nothing should change when we do that. The state before and the state after from restoring should be the same. All right, so we have our exec writer T, our run except T, save game state foo, default game state. So only other thing we want to make sure is that it writes to our like predefined path. So I'm going to save that one for later, because kind of have this one already written out. Should write save files. The engine's path, home users directory. All right, so we're just testing that the results of this should be in this path. I don't know that we care so much about, well, at least in this test, what's actually written here. So I wish we could kind of ignore that. In which case we want to pull out that part of the result. So let's do that on the left side of the equation here. The first test code, so we like had, you know, it's not going to be so bad because we know that it should be, and if it isn't, then we've done something really bad. And that would make this top. Actually, it would just be a file path. That was basically what I'm crunching it down to. File path. Path. Oh, I can't type for some reason sometimes. When people are watching, it's really hard. Okay. Couldn't match type IO unit with string. Expected file path. Our actual type. It's expectation. Yeah. It's inside the braces is the file path. Okay. So this is B0. So it doesn't know what that type is in there, right? So this, in our constraint here, it's kind of figuring, it can't figure out what this is. So we need to basically add a constraint somewhere in that case, or fill in a specific type for that thing. Now, what are we saying here? When we say we run this action, this the save game state action here, that it returns a result, which is not what we're doing here, right? We're just returning pure things. So file path and some text. It's ultimately what we want, which, of course, this isn't going to do that. This is just unit here. We could just put a tuple like this, perhaps, if GHC would let us. Yeah, I think that's okay. A couple of warnings there. Look at those. And we should fire up our test suite. So stack test takes the same parameters as build, I believe. So it can take fast and file watch. Run those. Oh, of course, we got to run it in our project directory, which currently not doing. Projects. Adventure engine. There we go. This is the one we want. Stack. Test. Fast. File watch. Boom. Okay. So that's going to tell me I'm like completely wrong and it's totally busted. But that would be a good step to have. Maybe some good progress. Okay, yeah. So there we go. It's totally wrong. So still can't figure out what this type should be, even with our helpful attempt at changing the code to make it more obvious by fixing our return type. So let's go to the test code. All right, I can't figure that out. So we could fix this with what? How could we do this? We could tell it by type applying something, perhaps, or let's see. That's what we want. Yeah. How do I get you to select this instance? I just have to fill in B0. So B0, if we're doing type applications, right, we might be able to do it. It depends where in the, yeah, what order it happens in. Meh. Yeah, let's enable it too as a language extension. Now I've lost stack GHCI here. Right, so that's not the right type. Now we want to type apply. Let's just ignore that one, and maybe it's this one. That's the M. Now we're not be able to do that either. What if we tell result? What result should be? Maybe if we tell what we expect result to be. So if we tell GHC the type of result is a list of file path to text. Will you find that instance now? We need scoped type variables. we need scope type variables for that? I mean, if we do, let's try that. Maybe. Okay, scope type variables it is. Let's get rid of type applications since we're not really using that. Scoped type variables is the one it wants. Or it's suggesting anyway. And we need scoped type variables for that. Hmm. Can't tell it that way, and perhaps I need to figure out a different way to tell you what the type of result should be, or the type of result is. Maybe I can put that here. It's gross, but so far so good. Cool. Yeah, I don't like it, but in order to tell GHC what B0 is, we kind of had to like fill it in somewhere because the inference engine couldn't figure it out on its own. Now it can because I can put that there. The scope type variables thing is basically like this doesn't have any in there, either to save game state or to fill in. So putting it on the left side of the arrow there wasn't gonna fly. Since I don't have that explicitly put out like I would have like for all blah 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 blah. You might have seen that syntax before. So that's fine for now. It's just test code, so doesn't have to be perfect or amazing. Hopefully it's not going to break for like inference isn't going to break for our users too badly, or which is we need ourselves in our own code, so we won't have to do this in our actual user library code or application code or anything. Some redundant do's. Okay. So the file path isn't right. We've got to fix that. It's going to be image origin saves /foo. That's what we expect it to be. So saves /foo. Okay. Not a super like useful test, but good enough. I mean, it specs out kind of where we expect saves files to go. But it's really just to get me started and going kind of thing. And get us somewhere. Okay, so that's good. Now the more useful stuff. Not so redundant do now is going to be necessary because we're going to have more than one thing here. So it should restore default state from save file. Cool. So the save result of this should be probably don't need the braces there. And we want to also run the load action load game state. Right. Probably a similar sort of, I think, but except we have load is read files state. Exec state E. On accept T. Load game state. We want to load the foo file. Okay, we should get back a game state. And now, the test that this worked properly is that the game states should be the same. Now, I don't know if we have an eq instance on game state that we could use. Because we use the world, for example, uses maps. Oh, we do have eq. So that means world must have eq. And all the maps have eq and everything in there. So we should be able to get default game state. Should be just the loaded game state. They should be the same thing. Alright, so saving it and then saving it to a file and then reading that file back should result in the same game state. Now we don't have that defined, which I think is what the problem is here, so we should probably have that as well. As well as some imports. Import control dot monad dot state dot strict. Should probably be that one there. Yeah. Skadoosh. And that's fine. Okay, now we just have the load game state doesn't exist. Load game state. So we have a monad read file. File path. And we have an accept T game error. And a game state. Let's leave it undefined and just see if we get the probably a runtime error. We hit undefined there. That's what I think we will get. Not quite. Not quite. So load game state is applied to too many arguments. What did I apply it to? I didn't apply it to anything. There we go. Okay, and we are here because we could not match the expected type, IO of game state, with some function. Likely, very likely. We didn't just stack this. Here. Okay, no show there. And here's our hole. Some M0 to either game error or game state to IO of game state. That M should be our state. All right, read file M T blah blah blah, right? Mm-hmm. Actually, yeah. Wait a second. I'm getting this isn't going. This isn't going to work quite the way I am going on about here. Because the instances are defined separately, right? Like, we're not actually going to be able to write the file, you know, and then read the file back. Because we have to provide a stub file system. This thing. So we actually do need the file path and the contents here to implement that. So load game state's going to need, or exec state is going to need some initial state. Right, and our stub read file is this list of, in fact, exactly this list here. Yeah, so we can probably just go like this. File contents, that. Pop that over here. Okay, and now what do we got? Load game state. I think it's a list of A0s. Because we're probably not using the right run state function, perhaps, for this. Or we're just not getting what I'm thinking we get back. So exec state t, if I remember correctly, returns the return value and the final state together, like something like that. So we should fix that. Pop. I think it's run state we might want, or we can just pull it out, the result. Skabope. Yeah, eval state ends up just the return value of the state computation. Oh, exec state. Yeah, I'm using exec state, which is running S, which is the final state, which is the list. So we want run eval state, not exec. Sometimes I get those mixed up. And now we get back the result of our computations, which is either game error or game state. So we're expecting to be a right default game state. It should be the same thing like that. But we don't have a show instance for it, for one. And for two, potentially the same issue with, can't figure out what the types, the return types are. Well, actually, yeah, that does, if you look at the prior test, it does return a list of those things. So this doesn't even need to be in a list. Maybe the inference will kick in there. Still can't do a show, of course. I haven't fixed that, but still can't find the instance for our monad read file. And monad write file. Okay, we're still having troubles with that. Let's see if that annotation trick works again. Oh. Interesting. It's picking the lazy state. That's probably what we don't want. We probably meant strict state. Okay, let's see here. Now, what we got? We have load game state, not no, still can't find the monad read file instance for that. State T. I expect one more kind of state T, of course. Let's see if I can give it to you. You don't like this. You don't like it. What am I doing? That should be fine. I don't know why that needed monad IO. Shouldn't have it, I don't think. Okay, let's see here. Monad read file state. Let's it's a file path. It's an accept T game error state. So when I run it like this up here, up here, eval state on file contents. So I run accept T load game state, which peels off that cat. M, our inner M should be, we're saying, should be a state T over this. Whose inner M, in this case, should be the context of the test, should be IO. Which is like the bottom of the stack. Right there. The second argument, namely load game state. Oh. Yeah, that should be right, I think. Eval state takes the initial value, takes the state passing computation to execute. We flip those arguments around using this trick here, so that we can give the initial state first. Run accept T should give us back our state computation. Ooh. Yeah, we probably do want state T here. Well, maybe the M comes after, like that. Some monad. Ba, ba, ba. Okay, yeah. That's what I was missing there. It should have been state T. Of course. With an M on the end, instead of in the middle, when doing the class constraint like that. Okay, fine. Good to know, good to know, good to know. So the last thing that we don't have is show for game state. We have eq, but we don't have show, and I guess should be is demanding a show instance so that if there was an error, it can print out what the differences are, I guess. And a game state probably doesn't have a show, I bet. Because world has a show. Why doesn't it have game state have a show? Can we just add it? Maybe that was just an omission on my part. Let's see GHC. What do you think? Maybe it was just an omission on my part. There you go. There's your show instance. Cool. Now we got the undefined I was expecting earlier. Much better. Okay, so a bit of a slight diversion. But we made it. We're okay. We haven't lost any limbs yet. I still have my brain. It's not leaking out my ears. Bleh. Okay. So now we need to implement, of course, load game state so that it doesn't, it's not undefined anymore. And then we actually need to implement save game state, of course, as well, for both of these tests to pass. And to test pass, pass properly. The silliest thing I could do to make this pass right now probably would be to just pure default game state, right? Probably the silliest thing I could do. I would trivially make the test pass. Which is not terribly interesting and not very useful, right? Because it's just ignoring whatever input we give it and not doing anything neat with it. So let's not do that. How can we serialize the game state? Can we just give it a straight up ASON instance and serialize it straight to JSON? Well, that really depends on, I guess, some of the objects in the hierarchy here of game state. So, the typical library we use in Haskell a lot, called ASON for serializing things to JSON. Super simple to use. Really well supported, active development. It's a pretty good package. You wouldn't go wrong choosing to use this package. So let's give it a shot. Let's go that route. Let us update our package file. I don't think we have it, so let's add the dependency. ASON. Looks like it's probably a transitive dependency anyways. We have to download and build it, which is great. Probably used by Gnome or... So there's that. ASON, pretty straightforward to use. We're going to import data.ason, JSON. Now for most very simple records with basic types, like ASON can serialize most things. Most records with like default kind of like primitive types pretty straightforwardly, because it implements a lot of the instances needed to serialize them out of the box. So in order for us to do that, there's a couple of different options with ASON. We can go the template Haskell route and have the serializers and deserializers generated for us at compile time and then compiled in our modules. Or we can do it with runtime generics, which is also fine too. Both are pretty good. They have different trade-offs. I don't suspect they're going to be really terribly interesting for a project this small. So I'm going to go with the generics just because, like, it's easier. Or, I mean, template Haskell is just as easy, but it's just pretty straightforward, I guess. So you just have to derive generic, and then you can get your instances for your records. And so what generic will do is it'll look at the generic representation of this structure, kind of walk through the tree of that, and reflect out the parsers and serializers. Also, it calls it encoding and decoding. That's the gist of it. So let's go ahead and try that. generic. Game state. And we got to import generic, of course. That doesn't come in base. It's ghc.generics. I think you have to import it from GHC if I'm not mistaken. Kind of a implementation defined thing. All right, so that's fine. And now can we also get our to JSON and from JSON instance? Driving instance to JSON game state. Oh, sorry, JSON.toJSON. Squoosh. Standalone driving for that syntax. Language standalone driving. And so this is why I don't like adding headers, these extensions to headers or to files, because they grow. A lot of them are very useful. And in a typical project, we use quite a few of them. Let's see, not a stock driver, so we need to derive any class. All right, so then we need to add instances to a bunch of other stuff that is referenced in that. So we'll just follow the rabbit hole. The game error needs one. We've got to be able to serialize the game errors that are in the game state. Or do we? And now this is where I'm starting to think about having a separate type for what we serialize to disk to save the state of the game versus, you know, what we actually use in the game engine. So things like the errors, is that going to be very useful to save? The current errors from the session that we were just playing. Right, probably not, I don't think. Right, chap? I mean, I think that's pretty reasonable. Like, I don't think I really want to load up my game and say like, oh, look. So, what we probably actually want is have like a save game state. Which is a subset of the fields from the game state. Like, we definitely want to save the game world. We definitely need, well, we said we wanted to save the scenes. So that's good. And input buffer. This is one way we could do it. I probably don't want the input buffer, don't really need that. All right, that's one way we could do it. We could define these instances for this, have a function that goes between the two. Okay, so it goes from a save state to a game state as long as we can fill in default values for these, which we can. That's fine. The other thing we can do is, instead of trying to have a separate data structure just for the save game state that we serialize in and out, we just kind of hand roll apart the serializer instead of relying on generics and that kind of stuff. And then we can pick and choose which fields we serialize out and which ones we don't. That might work just as well. And it will give us some insight into the library as well. And we might learn some things about that. So why don't we try that way? So let's back out of the generic stuff. And go down that route. Okay, so instead of deriving it, for just implement JSON.toJSON, we have to implement encoding a value. So we need toJSON, and optionally, I think optionally we can do two encoding, which goes directly to a byte string builder. Not strictly necessary. I think the minimal definition is just toJSON, if I'm not mistaken. Let's get rid of that. So we get game state, and we only really want the world, the scenes. That's the other two can be meh, whatever. All right, and then we get a bunch of helper. We just get like an object, whoop, and a way to construct that. So object is just a constructor for ASON's representation of JSON values and constructs a JSON object. Right? And these are all of the different types, quote unquote, in JSON. And you have object, array, string, number, bool, and null, and that's it. Pretty straightforward. And then so we're going to do this thing. So we'll construct an object as well out of the key world, which I think is be equal dot of the JSON representation of world. And scenes. Maybe we don't have those yet. Maybe it's dot equals. And probably JSON dot. So I'm gonna import those operators. I think those are safe. I'm gonna clash with anything else. So we do this way, data.ason. It's dot equals or equals dot equals. Okay. It's fine. Sorry, equals dot. Oh, it's conflicting with the lens. I don't think we're using that from lens for now, so let's hide that from lens. That's going to get a little confusing though. Let's prefer lens. Let's keep qualified with JSON. And how do we do that here? It's not quite like that though. Like that's kind of weird. Well, maybe it is. Okay, pop that over there, make it look a little nicer. What's the problem here? And that's just going to be some annoying things. With overloaded strings. Super fun. Happy times. Eh. Oh, maybe we need... Yeah, I think we should be able to just use the... it's been a while since I've done this manually, but should use the instance, the 2JSON instance of the value there, if it has one. So the type errors we're seeing over here might be a little bit meh. This is-string stuff's kind of annoying too. I think one of kind of the nuisances with this library too might be that the key value pair it's talking about here in the objects constructor is specifically string. Which is weird. That should just work. Okay, and the other thing we can do with this too, maybe I can get back to the generic stuff to do it that way, because yeah, I'm just running into kind of annoying things. Maybe there's a way to do it. So ASON has a way to like configure the generic generation of the parsers and serializers. And the options, what options do we get? No, it's still going to look through the whole thing. I was wondering if it had like a field selector or something like that. But it doesn't look like it. Okay. I mean, that kind of makes sense. So we still have to kind of do it this way and fix these issues. Okie dokie. else can we construct a pair? Oh, what is it? Okay, well, let's fix this one then. Okay, you know, I'm gonna hide it. I'm gonna hide it from lens, import it from ASON. Get rid of that. Okay, that's better. Just farting around. Okay, do. So then we need a 2JSON instance for world and scenes. Let's see if we can define one for world. To JSON world. JSON of the world, rooms, objects, exits. Your P room, P inventory, P verbs. Do we need the log messages? Don't think so. So we'll leave those out, I guess, and see what happens. Pretty sure we won't need those. So again, we construct an object as well here. Rooms are going to be equal to rooms. Objects. It's going to be equal to objects. Exits. So on and so forth. All right, so doing it with JSON, of course, means like, yeah, players might be able to like hack their own save files, but again, not really my concern. If you want to hack your own save file and beat the game that way, go nuts. Go ahead. I'm not here to ruin your fun. I don't want to ruin anybody's fun. Okay. So I did mean JSON objects. Specifically. Cool. Now we got a bunch of other instances we need to fill in. But when you derive things generically, which you can do, of course, you don't have to write all of this stuff by hand. But even though we are writing part of this by hand, like there's still a lot being done for us under the hood, a lot of code being generated for us under the hood. It's kind of nice. Okay, so let's go down from the list. We need one for room. So let's try and derive as many of these generically as we can. Maybe we shouldn't have fully walked back from generics. Let's add it back in. Derive any class I think we also needed. So I meant derive generic. Goodness gracious. Okay. GHC.generics. Okay, now let's do it for room. Deriving instance of toJSON for room. JSON.toJSON. Entity IDs. Right. And that's going to be a little bit funky because the A is only phantom. I don't know that we'll be able to do it this way. Let's not give up hope yet. Let's just see if it works. It's a higher kinded type. Can we do it directly on the new type? Cool, we can. Sweet. All right. Well, that's nice, because now, I guess GHC was smart enough by walking the object since it's a new type. It's just an int under the hood, and it can figure that out by the generic representation, so that's nice. It's going to ignore the phantom variable in that case. Which is good. Good. We're only using the phantom variable here just for type checking purposes, so we don't mix up IDs for different objects because they're all ints for different types. So it's a thing that only really exists for type checking. At runtime, it doesn't. As long as all we got all our ducks in a row, it shouldn't matter. Things can happen, but hopefully they should be good. So just a few more. Let's see, let's jump to the next error. No instance. For rooms. So it kind of matters a little bit. Let's see if we can do it. Driving instance JSON.toJSON entity ID of room. Now it's got an overlapping instance error. It's overlapping with the instance on this. Maybe we do need it. We can leave it off like this. The problem with this is we have no generic. I put the generic up here on the new type. Would that be enough to satisfy you, GHC? That would. What's the problem with this one? Entity ID. exit. Okay. I'm going to move those up here next to the entity ID itself. To JSON entity ID of exit. We're going to need one for game object. Yeah, that should be good for those so far. Let's see. What else do we got? No instance for JSON.toJSON key. Entity ID room. Oh, Because, why is that? Why does it need that? So because in world rooms we use, must be that. Must be because it's used here in the map. And that's what you need to encode a map in JSON, I guess. To JSON key room, entity ID of room. Can I derive that as well? Apparently I can. Okay, so we just need one for game object. So let's go to game object. Add one there. Ba-bow. Deriving that instance. Oh, JSON.toJSON. Game object. We need generic on it to do that. That. No instance. JSON.toJSON object. Okay. Let's add one there as well. And that needs a generic. And we need one for container. So let's add that. And that's going to need generic as well. No problem. Generic. Bang. And we need one for item. Let's just add generic right away. And driving instance. Item, JSON.toJSON of item. Verb. Verb. Oh, where did we define verb again? New type.
I never knew anything like this in the whole of my
There
life.
it is.
This is a glass of water, colorless, tasteless. It contains
We'll do it like that. Use the new type. Deriving. We needed to JSON key for game object. Need one for exit. Generic. Deriving it. So this is like a super mechanical, of course. We're going this way, but that's nice. I kind of like that. JSON.toJSON. All right, it's generating the code for us, which is like so great. You know, when you do care about it, you can write it yourself by hand, of course, if you need to. You don't have to. The less I have to write, the better. Do JSON of exit lock. And we need one for entity ID. Hey, Kodak Troll says, why do I use the actual accept T in my type declaration instead of monad error type class? It's just the way I decided to go with it, I guess. There's like two ways you can do it. The way I'm doing it in this code is just the concrete types way. Not really backing things together a whole lot or using them in different contexts. So it was just more straightforward, I guess. But yeah, like you totally could write it more with like the more generic class constraint style, which is very, very flexible and useful. So not any particular reason, basically, is the answer. No problem. Yeah. Thanks for the question. I hope it was somewhat useful. Not terribly surprising, or made sense even. The answer, I don't know. Yeah, oh, sorry, we needed one for deriving instance for entity ID of, what was it, item?
It's like a curtain or a spider web. It passed right through.
Yeah, and then we need entity ID exit. Oh, that's duplicate, sorry. It was probably 2JSON key I was looking for exit, yeah. 2JSON key. And one for, I need JSON key for verb. Probably for the verb alias map. E. And verb, I need an entity ID as well. Yeah, we have 2JSON key verb, yeah. I don't know where you're getting your information there from, GHC. Maybe you're not caught up with me yet. Maybe my GHC ID process in the background is a little bit slower now. That's okay. It'll catch up. And scene. We need scene. So we can serialize those out to our save file. To JSON, JSON.to.json. Scene. We need generic for scene. We're getting there. For some reason it's not believing me about the verb. I mean, it's right there. Oh, verb, not entity ID, verb. Oh, I see, because we probably used a verb as a key. A verb itself, right. Okay. That makes sense. Which means we might not actually need these. Looks like we're good there. So let's not have that code if we're not using it. Verb. Type verb. JSON, to JSON key. Verb. Okay, let's just derive it separately. Deriving instance JSON to JSON verb. Okay, now what's this? Utilize new type deriving. We have derive any class. Let's turn derive any class off. Does that help? Okay, that's kind of an annoying error to have. Let's see here. We need generalized new type deriving for how we're doing some of the new type deriving stuff. But it's conflicting with the generics, the way generics is doing this. Which is using derive any class. We can use deriving strategies. Yeah. Okay, deriving strategies. We can enable that, and that just deriving strategies is another language extension that lets you pick, tell GHC how to pick instances for your classes. All right, so let's jump to these warnings. So like deriving instance here, right? We can say. I think it's this goes like this, like we can tell it right here. I forget how the syntax goes exactly with deriving strategies, so let's look at them. Especially with standalone. Sorry, we can put deriving any class instance. Okay. right? And so it's just telling, like, use the stock instances that are available, derive it from the new type, and then specifically any class here. GHC is just getting a little bit confused when we have those two, any class and generalized new type deriving enabled, because it doesn't know which strategy we want to use for the instance. Which isn't a super helpful way of explaining it, because I'm only using the words that are already in the definition. So it's one of those cool things about deriving is that you're like, hey, you know, GHC, go figure out how to write this code for me and just generate it. I don't want to write it. It's boring boilerplate, right? And there's just some ambiguous edge cases sometimes when you have some language extensions that try to do that for you, and you're not specific enough about which one to use. So GHC often errs on the side of caution and says like, I don't know. So you tell me. So we could use any class here, I guess, is the gist. Right, and then we can specifically tell it, use the any class strategy for deriving this instance. Generally a pretty good extension to use, I would say. I don't usually enable it by default, but just because like it's extra typing when most of the time, like even up to this point in this project, we haven't really needed it. But if you start using deriving a fair bit for this kind of thing, it starts to become pretty useful. So now here we have to be more specific about which deriving strategy we want. That's a warning we know about. This is any class. And another cool deriving thing that we haven't really used on the stream a whole lot yet, but is deriving via. So not only can you get GHC to pick classes for you, class instances for you, but you can also like attach those or pick those from other types. And so you could derive classes for your type via others, which might have them defined already, which is turns out to be pretty darn useful for in certain situations. Maybe we'll see some uses of deriving via in one of our projects at some point, but as with a lot of things Haskell, I don't really use it until I need it. Until you can't get away with it. So it's kind of like the make it as simple as you possibly can, but no more simple strategy of managing complexity. Okay, so that looks like we're just getting back to warnings. So how's our test situation going? Okay, so we're back to compiling again. Of course, the test isn't really, it's still kind of doing the trivial thing. So let's actually make it do the smart thing. And let's do it from like load game state, where we have a file, path. And let's actually read that file path. Read that file. So we have raw contents, raw file. And all we can do with, in our current context right now, is monad read a file, because we don't have monad IO or anything even on this M. All we can do is read a file from file path. Now we're running this M inside of accept T, so we're probably going to have to lift that action up into our current accept T context. I think that's how that's going to go. And now we have to use raw contents. And so we can, now that we have derived all that stuff, we can deserialize our JSON. Because we've done it by hand, we might have to derive from JSON for a lot of our stuff as well, which is going to be fairly mechanical as also. But that's what we want to be able to do. So our game state, we could go from JSON, our contents, or I think it's decode prime, decode strict, what contents of, and that'll give us a result type in either, which we might be able to directly use and accept T, I think. Maybe not. I didn't mean JSON dot, though. Might have to pattern match on it, which wouldn't be so bad either, really. Decode either? Or it's either decode. Is what I'm thinking of. Okay, so yeah, it's not gonna translate from the left and right thing into our things. We'll just pattern match on it. No biggie. All right, so we get a decode error, or we get our game state. And we can return the game state as our value. And in the case of a decode error, we can throw that error. Now, raw contents is probably the only thing that's complaining about right now because it's expecting byte string. We're getting a text from read a file because that's what we told it to. So we'll have to right, our decoder is not going to be a gamer object, it's a string. So we'll have to come up with some kind of file load error or save load error as a game error, new kind of game error. Let's make it text, though. Maybe we'll have to convert it. But, we have that in the scope, so it's not a biggie. So it'll be consistent there. T.pack. Apply that to decode error. Okay. The raw contents is our last little challenge here. Really wanted a byte string. We have a text. Full fair GHC. Tell us the function we need. I think T might have a straight to byte string conversion. We could put JSON.encode right there, apparently. But probably not what we want. No, because that's going to do JSON encoding on the string. We actually just want to change it to a byte string. T dot. I think there might be a text package for that. Text to byte string. Probably text dot encoding. It probably comes with text. Ah, okay. So we're going to import that text.data.text.encoding. Data.text encoding T. Hopefully that doesn't conflict with anything on T. Yeah, so we're in the from JSON state error, that's fine. Okay, doesn't look like it conflicts with anything on T, so then T dot encode UTF-8. Yeah, encode UTF-8. Okay, it wanted a lazy byte string. We're converting it to a strict. Ugh. These problems exist for reasons, but they're just kind of annoying sometimes. And Haskell to lazy byte string. Yeah, from strict. Okay, so we're gonna have to like import that as well, probably. Oh, let's lower there. Modified data dot byte string. Lazy. LBS. And LBS to or from strict. Okay, cool. Now we're left with just the from JSON for game state. And we're going to go back to the motion again of all of the instances. And give them from JSON as well. Now this is going to be a little bit tricky for the entity IDs actually. Because remember, the type parameter, the the type parameter to entity ID is phantom. So it doesn't exist on disk. But it does exist in the type, so it might be fine. It might be fine. Let's start with that game state. We're running a little bit low on time on the stream, but we'll see how far we can get here. So instance JSON dot JSON game state. This is where we're writing it from a hand because we just want to be a little bit selective about the fields. From JSON, and go back to my ASON documentation. So decoding is the decoding class from JSON is very similar. To the encoding. See, right, it looks basically like this. It uses this applicative style. This is an applicative style parser to construct value objects, which can be turned into instances of your class. All right, so this V here will be well, with object guarantees, this V will be a JSON value type of the object from the object constructor. And then this operator here just looks in that object for a key with this name, with this key, and then returns that value, which we then pass into our constructor. So JSON object person, or the game state as game state. Let's pull this over to the left a little bit. Right, we want to get the world. We need the scenes. And we can return an empty input buffer and an empty list. Well, is that not right? Parse JSON, sorry. It's a parser. We don't have those operators in scope. Hopefully they don't I don't think those conflict with anything in lens. Okay, then we got from JSON instances we need for scene and for world and so on and so forth. Let's go to world. Well, we're probably going to need these, so let's just go ahead and change all this to JSON business to from JSON. And world. Right, we have to implement this one ourselves. No problem. JSON dot from JSON of world. Where? Parse JSON. is with object world. All right, we're going to do world constructor f mapped over the function that's going to return the runes from that object applied to the function that's going to return the objects applied to so on and so forth. So exits, player room key, always the key, player inventory, player verbs, and we're going to empty scene messages, I believe. Yeah. So it's going to be JSON with object zero. And then we got to go through this list. Game object is going to need all that. Fortunately, this is going to be mostly just copy, paste, and modify. For you, from JSON. For you, from JSON. Oh. Mistyped something there. Boom. Okay, game object's going to need it. An object and that whole hierarchy. Container probably. And the benefit of this too is that we're actually, by defining all these instances too, which we were going to need to do anyway when we got to writing the authoring tools for the engine. So now that we have those instances there available, we can also reuse them. We're going to reuse them a fair bit, I think, throughout this project. So driving the instance for verb. And objet. Where are you? Oh. There you are. Cool. Oops, did I mess something up? 426. Oh yeah, yeah. We have to do game error text for save load error. That's nice. Save load error. Error loading save file. We'll just make the text of that message the file name. back to the couple of warnings. What do we got down here? Oh, we just have to add byte string to our dependencies. Now I suspect if this compiles, the test will fail, of course, because what we're going to be reading from the file, the test file, is we haven't implemented save file properly, so it's not going to even jive. We're actually going to get no such file. All right, so we didn't even read the right file. Okay. Let's go back to our spec now. Okay, so the game state currently has what does it currently get? Okay, so we're loading the stub with this data here. And our test implementation of read a file uses list lookup. In that list, the fpath gets stub files, and it's returning no such file. It's not in the stub files. Or at least it doesn't think it's in the stub files. Well, that's not quite right. So we should probably debug trace this just to see what we get in there. Put here debug trace and let's look at that. Show it that. Okay, stub files is being set properly, so that's fine. The lookup function then. Why is it going to that branch? Maybe we were just using the wrong code in load file. Okay, so let's get rid of the debug trace stuff. That's working. Right, because we're calling load game state with this called foo. That's not a full path. All right, we're just giving it a file name. That's why it's not finding it. So, that means load game state needs to not take a full path. It needs to take just a file name. And we're going to prepend the kind of agreed upon save file path we have. So we'll construct that like this for now. Hopefully the precedence order of these operators is fine. Good. Notification if it's not. Cool. Almost there. And it's about the test failure I expected. We get a save load error, failed reading, not a valid JSON value, blah, 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 blah. So maybe we want to hide the actual JSON parse message from our users, of course, because they're not going to know. I mean, unless they're actually hacking the save file, they're not going to know that it should be JSON, but no, that's good though. We're getting basically what we expect. And our test infrastructure is working pretty well too. Loaded. Let's do that. Get rid of that warning. Okay, and so we could probably make this test pass almost if we serialize out the game state that gets passed into save game state here. With our new serializer. Encode a strict game state. Might want it to be text, I think. We'll write a file. Yeah, it takes text. So that's going to be T to decode UTF-8. UTF-8. Just make this here. Sorry, JSON.encode. Oh, it doesn't import encode. Is it encode strict? JSON. ASON had to encode strict. It's okay, ASON, if you don't, I guess. We can do the conversion. Too strict. Still not going to work, but this time the test is going to fail because we're just returning pure empty here. Oh, but it does pass. That's not right. Well, because we rewrote it to the file, so that should pass. Yeah. We haven't tested that anything consumes the return value of this except t. But we know what needs to go in there right now, so we'll just put it in there anyway. We'll need we'll need the full. So we'll just define that here as a value. Right, we'll just yank that whole thing. That there, because then we got to put that here. And the contents of the serialized text, though. Text, yeah. I might not actually want to return that as a return value, but because, you know, maybe the save file gets pretty big, and nobody really actually uses that return value. But it's there, you know? Okay, the only thing we're doing now is we just have somewhere where we're just kind of printing out debug stuff. Okay. Alright, so we have a little test here, you know, using our kind of in-memory test harness to read and write files. So far, we have like a pretty basic suite of tests that really are just testing our ability to like our JSON instances and to JSON and from JSON instances. Which is pretty good to do anyway. And that just means that we should be able to now read a game state file from a JSON file and get the game engine to that state. So we should be able to next week implement the actual commands that call our save and load stuff and be able to save our game. We might need to do a bit of work around these sort of predefined save file paths, just to make sure that, you know, they're cross-platform and work well for most users. Or maybe we want to be able to, I don't know, let the author. I don't think we need to let the author really work on that. We just need to make sure that they kind of work cross-platform. The other thing I'm concerned about is like the user's home directory. This tilde is kind of a convention for POSIX-based systems to mean the current user's home directory. Same with like the dot prefix is kind of another convention used a lot there, but might not translate to things like Windows. So we'll have to see if there's anything in file path handling libraries for that. That's saving and loading our game save. And that's our save files. We're just going to serialize straight out to the JSON. With that. And that works pretty well. So, The nice thing about this too, of course, like I was saying earlier, is that we'll be able to reuse a lot of these instances for the authoring tools, and start building out that tooling to let people build their own, let myself build the game content in a straightforward way, and then maybe if other people want to use it to build their own games, they'll have those tools available for them as well. That's all I got for you tonight, friend. Hope you had a good one. Hope you've enjoyed. If you like what you saw, and you're new to this channel, you haven't dropped by before, don't forget to follow me on Twitch, if that's your thing. And you have notifications enabled, that will just let you know when I'm online. Generally, I do these once a week on Tuesday nights around 10 after 8 in the evening in the Eastern Standard Time Zone. Sometimes I do surprise streams. The other week, not last week, but the week before, we worked on learning how to contribute to GHC, for example. So you'll get notifications of those as well if you follow. Otherwise, just, it's cool. Just know that's when we usually do it. You can also get the link to the Discord channel from this link above here. Our Discord server is home to a bunch of other streamers as well, and a big community of other functional programmers using all kinds of different languages. So if you like Haskell, there's going to be lots of Haskellers as well, but lots of others too. People like to experiment and try different things as well, so there's a great community of folks there to follow and get involved with. And of course, there's a chat channel for this stream as well, so we can talk about your projects and what you're up to, and maybe a little bit if you had any questions about what you saw on the stream tonight, ask me there as well. I'm also for now on Twitter at Agent Ultra, and on GitHub at Agent Ultra as well. Let's just get this code up and committed, and the repo is Agent Ultra under Adventure Engine. So we're going to add the save file and load file functions. Okay, these can save and load file A games. Okay, what do we got local? Oh, I haven't pushed. Well, let's squish that up a little bit. Squish that one in there. Yeah, that's good. There. Yeah, push that to master. Okay. And so this code lives on GitHub at here. Adventure Engine. Agent Ultra / Adventure Engine. Okay, so you can follow me on GitHub as well if you like. Fork, star, whatever you want. We have a bunch of other projects that we've done on this stream, so that's cool. And if you're following on YouTube, you know what to do. That's all I got for now. May your monads always be free. May your types always check. Thanks for coming to hang out. I'll see you next week. Bye.